Okay, this will be the third video for the review assignment for Chapter 3, and specifically this will be problem number 3 on page 129. This is my second go around with this one. I had a little glitch, and so I've already done all the writing for this problem, and so I'm just going to walk you through what I've done. Question 3 says we've got a rock that we've thrown vertically, and its position is given to us by this equation. And then it asks several questions. So the first question, part A, asks us for the velocity, and so I know that the velocity is the derivative of position, and so that's 24 minus 1.6 t. Then it also asks me for the acceleration, which I know is the derivative of velocity, or the second derivative, and the derivative of this is going to be negative 1.6. So that gives me my answer for acceleration, and then my answer for velocity. Part B asks, how high did the rock go? And so what I have to ask myself is, what's happening when the rock's at its highest point? And so that would be, as the rock's traveling up, its velocity slows down because it's being pulled by gravity. And then notice here at its highest spot, it stalls out because its velocity hits 0, and then the velocity changes to negative. So velocity is positive, and then velocity is negative. We're looking for the top, velocity being 0. So I simply take my velocity equation, set it equal to 0, and solve, and I get 15 seconds. Part C asks, how high did the rock go? And so that's just a question of position at time 15. And so I use my calculator and plug in 15 for time into position, and I got 180 meters. Part D asks, when did the rock reach half of its highest point? And so I know that half of 180 is 90, and so what I want to know in this question is, when is position equal to 90? And so I set position equation equal to 90, move the 90 over, because at this point I recognized I have a quadratic, and so I decided I would try and factor this. So I set it up to factor, move the 90 over, and then I divided everything by 0.8, or I should say multiplied by a negative 1 over 0.8. And then that got me this equation. And unfortunately, it left me with this ugly decimal, so I decided factoring was a really bad idea. So I just took the values I had and I used the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. And a few calculations on my calculator, did the math, and I came up with a time of 25.607 and a time of 4.393. Because, again, on the way up it would hit half the height, and then on the way down it would hit half the height. And so, you know, if that was 90, then there's the 4 seconds, and then there's the 25 seconds. And then part E asks me to figure out how long the rock was in the air. So I know the rock stops being in the air when its position is 0. So I set the position equation equal to 0, and once again I go to factor, and this is easier because I have no constant term getting in the way. Factor out a t, and then solve the two independent equations. Obviously times 0, I'm at a height of 0, that's the beginning. And then do the math, and I get a time of 30 seconds is when I hit the ground again. And so that is my final answer.